Homework number 1 is on monomials and polynomials. So I'm going to start with number 2 as an example of how to simplify some monomials. So this one, if you follow order of operations, the multiplication part is going to come first. So these two things we're going to multiply out. So it's not really like a foiling situation. It's basically like the commutative property where you kind of reorder what you're multiplying these things in. So you're multiplying all three of these terms by all three of these terms, but you kind of regroup them so that you multiply the constants together, the x's together, the y's together. So don't think of it like foiling because it's not really the same thing. So we multiply the constants, we get a negative 8 times positive 2, and that's a negative 16. Multiply the x's, x to the 4th times x to the 5th. Remember, our exponent property says that we're going to add those exponents together. So we end up with x to the 9th. Same thing with the y's, y to the 3rd times y to the 2nd. We're going to add those exponents, and that will give us y to the 5th. And then once that's simplified, we have plus 7, x to the 9th, y to the 5th. Something we mentioned in the notes is that if you want to simplify monomials like this, you would combine like terms. So the only way that you can combine them is if they are like terms, meaning they are identical terms. So they have the exact same variables, the exact same exponents, and you notice that's the scenario that we're in here. They both have x to the 9th, y to the 5th. If that's the case, then we can add them just as easily as we might add a negative 16x and a 7x. And so we just combine the constants there, and this would end up being a negative 9, and then you keep the variable part exactly the same. You're not adding or subtracting any piece of the variable. All right, so that's one example for monomials. Down in the next set, we are writing these polynomials in standard form and then classifying them. So you classify them by the number of terms and then what the highest term would be. So this one, standard form, means you need to write them in decreasing order. So the first one would be the 4m to the 3rd. That's the highest exponent. Following that would be negative 9m squared, then minus m, and then the 25. So we know that it's going to be a polynomial because it's got more or 4 or more terms, and our highest exponent is 3, so that would be a cubic. So our classification here would be a cubic polynomial. All right, and then on to our last set, I'm going to do this subtraction one, and then we have a multiplication and then division on the next page. All right, so this one, the subtraction, be super, super careful when you're subtracting because the subtraction in front of the parentheses, a lot of times people remember to subtract the first term, but then they forget to subtract any terms that come after that. So with this one, we've got this first term right here, and then we're going to subtract this term right here. So we've got 8x to the 3rd minus 3x to the 3rd. So we have 5x to the 3rd. And then we can do the same thing with the following terms. So we have negative 6x to the 4th minus, be super careful with that subtraction, 8x to the 4th. So that will be negative 14x to the 4th. And then we have these constants, 3 minus negative 3. So that turns into addition. Turns it into a 6. The directions state that final answer should be in standard form, so that means it needs to end up back in the right order. So we have negative 14x to the 4th would go first because that has the highest exponent, followed by the 5x cubed, and then the positive 6. All right, and then on our next page we have an example of multiplication as well as division. So we'll do number 15 for multiplication. This one, remember, you can group them in any order that you want and start with either pair of multiplications. So I'm actually going to start multiplying these two together first because we can FOIL those, and then we're going to take the negative 3x and distribute that. So foiling these two first, and I'm just going to leave the negative 3x out front. So 5x times 8, we have 40x. Outside term, 5x times negative 2x would be a negative 10, and then it'd be an x squared. Inside term, 1 times 8's. Be 8's, and our last 1 times negative 2x is negative 2x. All right, so I'm going to distribute now that negative 3x from the outside. We'll combine like terms, then make sure it ends up in standard form. So distribute this negative 3x to this first term. We'll have negative 120, and our exponent will be x squared. Next term, negative 3 times negative 10 is positive 30. We'll have x to the 3rd. Third term, negative 3x times 8 is negative 24x. And our last, negative 3x times negative 2x would be a positive 6x squared. All right, so for my final answer, I'm going to combine any like terms, make sure it ends up in standard form, which means decreasing order. So my first one would be 30x to the 3rd. Next, I can combine my first and last term here. So negative 120x squared, positive 6x squared. So that will be negative 114x squared. and finally the negative 24x. So that would be your final answer for number 11. All right, we'll do one last one. We're going to do number 19, one of the division examples. So remember, the way these work is you are going to individually divide each one of the monomials in the numerator by the monomial in the denominator. So starting with this first monomial divided by this, so you kind of go expression by expression. So negative 42 divided by 6 would be a negative 7. X to the 10th divided by x to the 2nd. Remember, our rule says we subtract those exponents. So we'd end up with an exponent of 8, so that's 10 minus 2. Y to the 5th divided by y. Remember, this is technically an exponent of 1, so we would subtract those as well, and that would be y to the 4th. Next term, plus we're going to do the exact same thing for these two. So 12 divided by 6 is 2. X to the 8th divided by x to the 2nd. Subtract the exponents, we get x to the 6th. And the y is y cubed divided by y. Subtract to get y to the 2nd. And one final piece here. Negative 6 divided by positive 6 is a negative 1. You don't have to write the 1. That's just going to kind of be implied. X squared divided by x squared, also 1. And y squared divided by y, also 1. So if it only appears at one point, we would write a 1. If you still had variables, you wouldn't have to write a 1 in front of it. The variables would be enough. All right, so that is what your final answer should look like for number 19.